Hello everyone, Namaskar, Raj Krishna this side, and today we are going to solve one more problem from partial differential equation, and this will be under my playlist of application of partial differential equation. So if you want to have a look at some more problems of this type, so you can visit that playlist. I also have a playlist on partial differential equation, that is a separate one. So let's focus on this problem. We have to convert the given partial differential equation into its canonical form. So partial differential equation is given. So I have already discussed one problem. There are basically three types of problem. The equation can either be hyperbolic, it can either be parabolic or elliptic. Fine. So for all these three, in hyperbolic, the factor s square, let me first give you the normal form which we have, that is RR plus SS plus TT plus a function of x, y, z, PQ, this equals to 0. Now to give you a brief, if s square minus 4RT is coming greater than 0, then it will be hyperbolic. We have a slightly different approach for that type, for converting that type into canonical form. Then comes s square minus 4RT to be equal to 0, that will be parabolic. And then comes the last one, which is s square minus 4RT being less than 0, that is elliptic. So as I can see, the one problem which I had done was on hyperbolic. So in that case, that factor was greater than 0. Now I have, I think this problem, let's check that. So I will go step by step. So the first step which I have, which I am writing here, step 1 will be to check this is hyperbolic, parabolic or elliptic. So this is equation can be written as del 2z by del x square is nothing but r, del 2z by del x del y is nothing but s, so 2 times s, del 2z by del y square is nothing but t, so t equals to 0. Fine enough. Now if you compare, this capital R, capital S and capital T are just the coefficient of small r, small s and small t, which you already know. Okay, you already know that P is del Z by del X, Q is del Z by del Y, then comes R, which is del 2Z by del X square, then comes S, which is del 2Z by del X del Y, then comes finally T, which is del 2Z by del Y. So these are the basic things which you have been working with from a long time. So as I can see, my R is 1 in this case, my S is 2 in this case, and my T is 1 in this case. So if I find s square minus 4RT, s square minus 4RT, so let's check what that comes to be equal to. So 2 square is 4 minus 4 into 1 into 1. So that comes out to be equal to 0. And as I told you, if that comes to be equal to 0, that is parabolic. Fine. So this was the step 1 to check whether it is in which category it lies. Fine. So if it will be hyperbolic, then the next step will come. Step 1 is common to all of them. Rather, all the steps are common, just a few minor changes are there. So second step is to write the lambda quadratic equation. Which is a quadratic equation in lambda, and how we form that quadratic equation is important. R s and t, which we have already got. With the help of that, we found that quadratic equation. So that is r lambda square plus s lambda plus t equals to 0. So plug in the values. R is 1, so you'll get lambda square plus 2 lambda plus 1 equals to 0. Find the roots. So the roots will come real and distinct in case it is hyperbolic. The roots will come equal if it's parabolic. The roots will come conjugate complex it is if it is elliptic. So let's check that. So this is nothing but lambda plus 1 whole square. So as I told you, this will come real and equal. So the two roots which you are getting is -1 and -1. Fine. Now comes step number 3. So the step number 3 which we have is the characteristic equation. Which is generally dy by dx plus lambda 1 equals to 0, dy by dx plus lambda 2 equals to 0. Now because in this case lambda 1, lambda 2 both are equal to -1, so instead of getting two equation, you will get one equation only, because both of them have lambda. So dy by dx plus lambda equals to 0, so -1 equals to 0. This is the only equation which you will get, because the other one also you will get the plug in the value of lambda as 2 as also -1, so doesn't matter. So let's solve this. So dy by dx equals to 1. So from here we get dy equals to dx, integrate both sides. So y equals to x plus c. So y minus x equals to c. This is the only equation which you are getting. What's next? Can we have step 4 here, or should we move? Yes, we can move further. So y minus x equals to c is what I have got. So step 4. Y minus x. So generally we get two equation. Y minus x equals to c. I would have got any other, because as I solved in hyperbolic, we got two equations there. So one equation, instead of c1 we replace that by u, other in place of c2 we replace that by v, and we find everything in terms of that u and v. But here, as you have got only one equation, which is y minus x equals to c, so you can say that y minus x equals to u. So you have got u, but what about v? Because v finding v is really going to be an important equation. So we find that v by hit and trial method. So what does hit and trial method say? It says choose v such that the Jacobian of u comma v comes not equal to 0. So this is a case of hit and trial. So we can check for the values of v for which the Jacobian of. So let me give you a trick. Just change the sign and check whether it is not coming not equal to 0. So if I change the sign in the middle, so I get y plus x equals to v. This is just I am checking whether this can be my v or not. So let's find the Jacobian. So Jacobian of u comma v is defined by del u by del x, del v by first del u with respect to x and with respect to y, then v. v by del x del v by del y. Fine. So you have this. So del u by del x, if you find, so del u by del x is going to come as -1. Your del u by del y is going to come as 1. Your del v by del x is going to come as 1. And your del v by del y is going to come as 1 again. So if I find this value of this determinant, so -1 from here and -1. So -2, which is obviously not equal to 0. -2 is not equal to 0. So this which we chose randomly by hit and trial will be beneficial for us. So we got the value of v finally. And with this value of u and v, we are going to find the other values, which is the part of your step number 5, which says that find P, Q, R, S and T in terms of u and v. So starting with P, what is P? Your P is del Z by del X. Now Z is a function of u and v, and u and v are further the functions of, Z is a function of u and v, and u and v are the further the functions of x and y. So please keep this in mind. So del Z by del X if you want to find, so that will you find a del Z by del u and then del u by del X plus del Z by del v and then del v by del X. Sorry, this multiplication sign is in the middle. Fine. Now del Z by del u, z by del u. Okay, so we can't find this. So del u by del X, what we can find? Let me find it only. I'm not writing that. So del u by del X, u by del X, u is this. So that is -1. Fine. And del v by del X is 1. Fine. So my P, which is del Z by del X, is coming. Del u by del X was -1. So minus del Z by del u. And here it is +1. So plus del Z by del v. Fine. So this I got is the first thing. I also have to find a relation between operators. So if I equate the operator, then I will get del by del X equals to minus del by del u plus del by del v, because this will also be used further. Fine. So these two relations. Fine. What's next? Similarly find Q. So Q is del Z by del Y. So again del Z by del U, del U by del Y, del Z by del V, del V by del Y. Again del U by del Y, if you want to find 1, del V by del Y, both of them are 1. So similarly you can say del Z by del Y equals to del Z by del U plus del Z by del V. One thing you got this, maybe this will be used. Another on equating the operators. So from there you get del by del y equals to del by del u plus del by del v. This is the other relation. Fine. What's next? P, Q done. R, S and T. Okay. So R. R is del 2z by del x square. So del by del x of del z by del x. Now del by del x I can replace by this. And del z by del x I can replace by this. Fine. So these are just this operate on this. So just simply multiply. So del, you will get plus of del 2z by del u squared, del by del v, del z by del u. So minus and then okay, wait. Del by del u with this, then the same with this. So I will get minus del 2z by del u. Okay, fine. Then del by del v with both. So del by del v with this, if you do, so you will get minus del 2z again, del u, del v. Then del by del v with the other one, so plus del 2z by del v square. So you got this. Okay. So you got R also. So if you are interested in S, we have lot of space. I thought we need another page, but that is not okay. Fine. So what we have done till now, we have got R, then we come to S. So S is S you can find either by del u of del z by del x. Sorry, wait. What is S? S is del 2z by del x del y. So I have del by del x with me, I have del by del y with me, so I can write this as del by del x of del z by del y. Fine. Del by del x, I have relation with me minus del by del u plus del by del v, minus del by del u and what about this del z by del y? So del z by del y was del z by del u plus del z by del v. Del z by del u plus del z by del v. Fine. So your S is, just multiply. So minus del 2z by del u square is what you will be getting. Then this multiplied by the last one, so minus del 2z by del u del v, then 2z by del u del v, then this if multiplied by this and this, so del 2z by del u del v with a plus sign, so this of course will get cancelled, so you are getting your s as del 2z finally coming to your t. So what is your t? Your t is del 2z divided by del 2z divided by del y square. So that will be del by del y of del z by del y. So what is your del by del y? Del by del y is so del by del y is del by del u plus del by del v, and this will del z by del y is del z by del y is del z by del u plus del z by del v. So del z by del u plus del z by del v. Just simply multiply this. So I'm getting my t as del 2z by del u square is the first thing. Then I am getting, just multiplying this, then I am getting del 2z by del u del v, del 2z by del u del v twice, so 2 times del 2z by del u del v, and finally del 2z by del v square, del 2z by del v square. So this is, we got t, we found p, we found q, we found r, s and t. Now put that back in the initial equation that we had. What was the initial equation that we had? R plus 2s plus t equals to 0. So do I have a space? Finally I have a space. R plus 2s plus t equals to 0. Carefully put, carefully put. So R is, where is my R? R, where are you? R. So R is this lengthy looking thing, which is 2 times del 2z by del u del v, which I didn't write. So del 2z by del u square minus 2 is just like a minus b whole square, isn't it? So del 2z is similar to a minus b whole square. Fine. So this is r plus 2s plus t. So r is del 2z by del u square minus 2 times del 2z by del u del v plus del 2z by del v square and 2 times of s. What is my s? S is this. So 2 times of this means minus 2 del 2z by del u square plus 2 del 2z by del v. Just we have to write, don't need to think much. Then we have t, and this is your t. So simply write this t, del 2z by del u square. Wait. Was there any 2 times? Yes, 2 will come here. 2 will come because del 2z by del u del v, del 2z by del u del v came twice. So 2 times del 2z by del u del v, and finally del 2z by del v square. Now comes the simplification process, and this is equal to 0. So what is getting cancelled? Minus 2 times del 2 z del u del v is the first thing which I am seeing getting cancelled. Then del 2z by del u square is also 2 times, which gets cancelled eventually. One time there and one time here. With this, del 2z by del v square is what remains. And how many times? 1, 2, 3 and 1 4 times. So 4 times del 2z by del v square is 0, because r plus 2s plus t was 0. So what you are getting? 4 can be dumped to that side. Del 2z by del v square equals to 0. This is the final thing which we are looking for. So that's it. As simple as possible. So fine. What can I do here to make it simpler? Might be looking a bit, no. I think this is fine. Wait a minute. Yes, this must be fine for you. Very small things. As you can see here, what was the first step? This one was the first step, where r plus ss plus tt, we compared to that and we found in step 1 that it was a parabolic. Just look at your notebooks, not at the screen. Just this is just for me. So step 1, we saw it was parabolic. Then step 2 was lambda quadratic equation. So we found lambda is equal, which it comes in parabolic. Then in step 3, dy by dx minus, then we have dy by dx plus lambda 1 dy by dx plus lambda 2 equals to 0. In this case, because both were equal, so we got only one equation from there, that was y minus x equals to c. Then we came to step number 4. Because we wanted v, for that we have one relation, Jacobian of u comma v must check, hit and trial, that check whatever v you are choosing by hit and trial. For that v, Jacobian of u comma v must not be equal to 0. So we got that. So v was y plus x, and then started journey by finding p, then q, then r, then s, then t. Finally put them all into the primary equation, which was r plus 2s plus t, and then we got del 2z by del v square equals to 0. That's it from my side. Might be a bit boring for you, but not for me, because I'm also in learning phase in this particular concept. Do watch more of these on my playlist on application of partial differential equation. That's it from my side. Share this video to your friend. Thanks and have a very nice day.